Hello, my name is Mr. Asprey and this is EDEXCEL 2022 AS Pure Maths. This paper is great to do if you're in year 12 and you're halfway through the course. It's also good to do as well for practice if you're in year 13. So there's some tricky questions in here, particularly the one on circles. Give that one a try. And if you do find this useful, please do subscribe to the channel. Please do like the video. Please do share it with your friends. I've set a target of trying to get 1,000 subscribers by the end of this exam period. So if you can help me on that journey, that would be absolutely fantastic. Okay, let's do it. Let's get into this paper. Okay, question 1 is on integration. Okay, so in order to integrate, we need to write it in the correct form. So I want to integrate 8x cubed. That's good, that's in the good form. Now this one here is not. I want it to be minus 3 over 2. And then I need to change this x so that it's just x to the power of something. Well, what is that something going to be? Well, first off, it's square rooted. And if we square root, that raises the variable to the power of a half. But it's also on the bottom of a fraction, which turns the power negative. So the negative because it's on the bottom, and the half because it's the square root of. And plus 5 is good to go already. Okay, how do we integrate? We take the power, we up it, and then we divide by the new power. So this gives me x to the 4, and then I divide through by the new power. This one here, I up the power by 1, so minus a half plus 1 is a half. So the new power is a half, and then I divide by that new power. And next, 5, this is essentially x to the 0, and when I up that to the power 1, this becomes 5x to the 1, and I divide by the new power 1. And whenever you integrate, you need to write plus c unless there are limits given to you in the question. In this case there are not, so we write plus c. Okay, 8 divided by 4 is 2, so that's 2x to the 4 minus, so we do minus 3 over 2, and then that is divided by a half, or 0.5. And that gives me minus 3, and that's x to the power of a half, and then 5 over 1 is just cos 5. And that is our final answer. Next question is factor theorem, and it says show that x plus 3 is a factor. Well, what we know from the factor theorem is that if x plus 3 is a factor, that implies that f of minus 3 will equal 0. And that works both ways as well. So we need to show that. We need to just substitute minus 3 in and show that it equals 0. Because it's a show that question as well, we're going to need to show every step. So I'd write 2 lots of minus 3 cubed plus 5 lots of minus 3 squared plus 2 lots of minus 3 plus 15. And I'll do those calculations. So minus 3 cubed is minus 27, times by 2 is minus 54. Minus 3 squared is 9, times by 5 is 45. And then we've got 2 times minus 3, which is minus 6, and plus 15. And I think now it's safe to assume that we can total this up and say that this equals 0. And then finally, to get the full marks, we have to say, as f of minus 3, equals 0, then x plus 3 is a factor of f of x. We need a conclusion statement there to get all of those marks. Okay, next it tells us that f of x can be split up into the factors x plus 3 multiplied by some other quadratic factor. And we can find out what that extra factor is by doing polynomial division. So I'd write x plus 3 outside, like that, and the polynomial we're dividing is 2x cubed plus 5x squared plus 2x plus 15. Okay, so we look at the lead terms. We've got an x and we've got a 2x cubed. And if we divide 2x cubed by x, we get 2x squared. We then multiply that down by the x and the 3, which gives me 2x cubed. And 3 times 2x squared is 6x squared. And then we subtract. 5 minus 6 is minus 1x. And we can bring down that 2x there. And the 15. Now this is my new lead term, minus x squared divided by x will give me minus x. Multiply those by that factor x plus 3, and that gives me minus x squared, and it gives me minus 3x. Draw a line down, subtract 2 minus minus 3 is 5, so 5x. And bring the 15 down, and this is my new lead term, 5x. If I divide it by x, I just get 5, so plus 5, and then just to double check, multiply these down, and hopefully we should get 5x plus 15, which we do, and therefore when I take away finally I get no remainder. So I can write f of x is equal to what we divided by times by what came out of that division. And this tells me that a is equal to 2, b is equal to minus 1, and c is equal to 5. Great, that's that part done. Next part says, hence show that f of x equals 0 has only one real root. Okay, well, if I were to set f of x equal to 0, I know that it's x plus 3 multiplied by 2x squared minus x plus 5. And I know that we can get a root coming out of this bracket here, because x equals minus 3 makes that bracket 0. So what it's saying is that show that this part has no real roots. And we can tell how many roots a quadratic has by using the discriminant. So the discriminant of that quadratic is always b squared minus 4ac. And in this case, the b term is minus 1, so minus 1 squared, minus 4, the a term is 2, and the c term is 5. And this gives me 1 minus, and then I need to do 4 times 2 times 5, which is 40, so 1 minus 40, which is minus 39. And this is less than 0, and when this discriminant is less than 0, it has no real roots. If it equals 0, it has 1, and if it's greater than 0, it has 2. But if it's less than 0, it has no real roots. So we can say, therefore, 2x squared minus x plus 5 has no real roots. Therefore, f of x has only one real root, x equals minus 3, which you don't need to actually put, but that's just a little cherry on the top, as they say. Right, next part of this question. Write down the real root of the equation f of x minus 5. Well, what is that as a graph transformation? Well, I think what you remember is that if it's inside the bracket, it affects the x, and it always does it in the kind of opposite way you'd expect. So it's going to be a translation in the x-axis by 5 to the right. So it's going to shift the whole graph 5 to the right. And therefore, all the x values will shift 5 to the right. So the new root, so this is part D, the new root will be x equals minus 3 plus 5, so x will equal 2. And we're done with that question. Okay, next one, we're asked to work out Q to R. This looks quite tricky, so it's always a good idea to draw a picky when it's tricky. And let's just draw P here and Q there. And we've also got P to R, so I might just draw that there, just completely randomly. Doesn't really matter. And we have been asked to work out Q to R in that way there. Okay, so how am I going to get there? I'm going to go the wrong way down this line, and then I'm going to go adding on the right way down that line. So Q to R is equal to Q to P plus P to R, and going the wrong way, going Q to P is going the wrong way through P to Q, so it's the negative of that. So it's the negative of P to Q. To flip that one around, and P to R, we're going to take the positive of that. Okay, so working this out, it's going to give you minus 3 plus 13, which is 10. And minus 5 plus minus 15 is minus 20. And so we can write that as 10i minus 20j. Okay, and next it says find the modulus of that vector. Well, the modulus we find by doing Pythagoras' theorem on the components. So that's going to be 10 squared plus minus 20 squared, all square rooted, which I'll just put into the calculator to avoid any errors. So 10 squared plus negative 20 squared is the same as 20 squared, and that is 10 root 5. Okay, next we have the point S lies on the line segment QR such that Q to S to R is 3 to 2. So it's going to be well, it's going to be closer to R, so it's going to be about here, and this is going to be 3 shares, and that will be 2 shares, and that will be S, and so there'll be out of 5 shares in total. So it'll be 3/5 along and then 2/5 along. P to S is going to be P to Q and then 3/5 of Q to R. So P to S will equal P to Q plus 3/5 of Q to R. Okay, what was P to Q? We knew that one already. That one was 3/5. And then we need 3/5 of Q to R, which we worked out over here, which is 10 minus 20. Okay, great. So 3 plus 3/5 of 10 is 9, and 5 plus 3/5 of minus 20 is minus 7. So we can write that as 9i minus 7j. Perfect. Okay, next question, and we have a non-right angled triangle. We have an angle given, and all of the side lengths are in terms of x. And it's asking us to show that x equation can be found. And if we have all the side lengths and we have one angle, that means we need to use the cosine rule. And the cosine rule is, we'll call this one capital A because it's the angle that we have. And this one's little a, and then these ones are B and C, doesn't matter which order. So the cosine rule states that a squared is equal to b squared plus c squared minus 2bc cosine of capital A. So in this case we have 3x plus 10 all squared is equal to x plus 2 all squared plus 7x all squared minus 2 lots of x plus 2, 7x, and cosine of 60. Now, I know my exact angles, and I know that cosine of 60, conveniently, non-conveniently, I'm in radian mode. Okay, I'm out of radian mode, and I'm showing you there that cosine of 60 is a half, which you probably knew already. So if this is a half, then that's going to cancel nice and neatly with the times 2 here. And then I guess it's just an exercise in expanding. So I'm going to expand these double brackets quickly to save some time. I'm going to get 3x times 3x is 3x squared. I'm going to get 3x times 10, which is 30x, and I'm going to get another one of those, so it's going to be 60x. And I'm going to get a 10 times 10, which is 100. Over here, I'm going to get an x squared plus a 4x plus a 4. 7x all squared is 49x squared. Don't forget to square the 7 as well. And then we're minusing x times 7x, which is 7x squared. And we're also minusing 2 times 7x, which is 14x. Okay, great. Let's collect up all the x squareds. So we have 9 on this side, and on this side we have 50 minus 7, which is 43. And the x's, we have 60, and we have 100. And over here we've got minus 10 plus 4 is minus 14 plus 4 is minus 10. And we've got a plus 4. Okay, let's bring everything over to the right side because it's got the higher, it has the higher number of x squareds. So minus 9x from 43 gives me 34x squared. Minus 60 from minus 10 gives me minus 70. And minus 100 from 4 gives me minus 96. And finally, we can divide all of these by 2. And we can do that because it's equal to 0, and dividing 0 by 2 just still gives you 0. Great, we've shown it. It says hence find the value of x, and that's 1 mark because you don't get any marks really for solving quadratics, or you don't need to show any working for it. At least you can go straight to your calculator, polynomial, degree 2, and we've got 17 minus 35 minus 48. And we get 3 and a negative. And it can't be the negative because we're looking at distance here. So x must equal 3. And then it says, hence find the value of theta, giving your answer to 1 decimal place. Okay, so what do we know? Well, we know x is 3, so we know this side length is now 5. And if x is 3, this is 19. So what we have is we have a side length with an angle opposite, which we're trying to find, and we have a side length with an angle opposite, which we have. So we can use the sine rule here. And I'll start by writing sine theta over 5 is equal to sine 60 over 19. So sine theta over 5 is equal to sine 60 over 19. Multiplying both sides by 5 gives me this, 5 lots of sine 60 over 19. We go to our calculator and we do 5 lots, whoops, need to go into calculation mode, fraction button, 5 lots of sine 60 over 19. It gives us 5 root 3 over 38. And then to find theta, we just do the inverse sine of that. And on our calculator, we do shift sine of the previous answer is equal to, and we get 13.2. Rounded to 3 significant figures. Perfect. Next question, let's go. Okay, classic log graph modelling here. We've got mass, algae in a small pond, and we've got this equation here. And we've got P and Q are constants, T is the number of weeks, that's important, and mass of algae was first recorded. Data shows there's a linear relationship, and you have this equation here. And then use this to find a complete equation for the model. Okay, so the first thing we do is we take this model and we break it down using logs. So the model was A is equal to, oops, I've forgotten it already, PQT. We log both sides. We then split up that log by writing log P plus log QT, because whenever you have two things multiplied together, we can split a log up and put a plus sign in between them. And then also what we could do using log rules is we can bring a power down and it becomes the coefficient. So T log Q. Okay, then we've got to look at how that compares to the equation that we've given. So we have log A on the left, that's good. And then we have some number times T plus some number. So I'm actually going to write this as log A is equal to log Q times by T plus log P. And now what I can do is I could take that equation that we're given right there and I can write it directly, I'm going to write it directly above here. So log A is equal to, and then it was 0.03 times by T plus 0.5. And now we can compare. So we have the variables log A and log A, that's perfect. We have the variables T and T. And that tells me that this 0.03 and log Q must be equal. So I can say that log Q is equal to 0.03. And I can also tell that 0.5 must equal log P. So log P is equal to 0.5. Now, just a quick reminder, these are all in base 10. So really I should have written log base 10 down there. And to remove a log base 10, I need to take all of these values of powers of 10. So I can say that Q is equal to 10 to the power of 0.03. And P is equal to 10 to the power of 0.5. Okay, then we just work those out. So 10 to the power of 0.03 is 1.072. And then 10 to the power of a half is 3.16. And did it say to, oh, 4 significant figures, so there needs to be a 2 there. Okay, and then finally it does say you need to find a complete equation. So I need to write that in that equation form like this, using those numbers which we've just created. So my final answer will be A is equal to P is 3.162 multiplied by Q, which is 1.072, and then you raise that to the power of T. So that's my final answer. Okay, so if we look at this, model here, and it's if t is 0, then we get q to the 0, which is 1. So just a is equal to p. So t is equal to 0 means it's initially, like as the model starts. So p is the initial amount of mass of algae in the pond. And then Q is what we multiply the initial amount by. And we do that every single week. So therefore, Q is the ratio of algae from 1 week to the next. So for example, if that was a half, then it means that every week the algae is getting halved each time. Okay, part C, it says find the mass of the algae when T is equal to 8. And then the next part says the number of weeks it takes for the mass of the algae to reach 4. So this is just subbing into the this equation, this green equation here. So first off, we have when T is equal to 8. So we have algae is equal to 3.162 times by 1.072 to the power of 8. And we just pop that into our calculator. To the power of 8. And we get 5.5. And that's in kilograms. You have to write the units, otherwise you will not get the marks, unfortunately. And then the second part of the question asks us to find the number of weeks it takes for the mass of algae to reach 4K. And the first question, I used this model. And in fact, for the second part, I'm going to use this one because it has T just not as a power. It's going to make it easier to use. So I would write that log of 4 is equal to 0.03 T plus 0.5. So therefore, rearranging this is going to give me log 4 minus 0.5 is equal to 0.3 T. So T will equal log 4 minus 0.5 over 3. 0.03, sorry. Great. So I would do log, and that automatically does base 10. Minus 0.5 is equal to, then divide that by 0.3, and we get 3.4. And the units for that would be weeks, as given in the question. Okay, and final part, state one reason why this might not be a realistic model in the long term. Well, again, if we look at this model here, this is showing that every single week the algae is increasing because we're multiplying by 1 point something each week. So the algae is going to continue to grow, which is unrealistic because it might run out of resources. So really it's unrealistic because the model predicts unlimited growth. Okay, we're done. Okay, here we have a binomial expansion, and we have the 8th power. So I will start by writing 8C0, and then I will multiply that by the x term, which is minus 2x over 9. That will go to the power of 0. And the numerical term 3 will go to the power 8. And then I will add on 8C1, and the x term will go up by 1 to the power 1, and the numerical term will go down by 1. And we'll just carry that on. Minus 2x over 9 to the power 2, multiplied by 3 to the power 6. And it wants the first 4 terms, so we've got to do one more. Minus 2x over 9 to the power 3, and then 3 to the power 5. Okay. On this big calculator, if you have it, which I recommend you do, You can get that C button there by pressing Options, go across to Prob and press C, and then 0, and then we'll multiply that by minus 2 over 9 to the power 0, and then we'll multiply that by 3 to the power 8. And we will get 6561. And then I recommend just keeping that in the calculator, that value, that working there, and just going back and changing them. So this changes to a 7, this changes to a 1, and this changes to a 1. And also we're going to have an x power to the power 1. So we've got x here to the power 1. So that will be minus 3888x. And then we go up again and we change this one to a 6, this one to a 2, and this to a 2. And that will give me plus 1008, and this time we will have x squared. So that's x squared. And then finally, we'll just do the same thing again. That'll be a 5. That'll be a 3. And that will be a 3. And it gives you minus 448 over 3, and that is x to the power of 3. Okay, part B asks us to multiply that binomial by this bracket. Now that bracket, first off, can be rewritten as x over 2x minus 1 over 2x, which is the same as 1/2 minus 1 over 2x. Okay, now that we've got it like that, we can ask ourselves the question, if I multiply it by this expansion here, how are we going to get x squared come out of this? Well, one way we're going to get an x squared come out is if we take the constant term here and multiply it by the x squared term. So that will give me 1/2 times by this, and that will give me 504x squared. But the other way that I can get an x squared is if I take this term and I multiply it by this one. Because this is a divide by x, and that's an x cubed. So timesing a 1 over x by an x cubed is just going to give me an x squared. And that's the only way that we're going to get x squareds when expanding these brackets. So the other one will be minus 1 over 2x multiplied by minus 448 over 3x cubed, and that will be minus 1 over 2 multiplied by minus 448 over 3, and great, that gives us a positive 224 over 3 x squared, because again the x on the bottom will cancel with one of the x's here to give you an x squared. So in total, how many x squareds have we got? We've got to add those two together. So add on the 504, and we're going to get 1736 over 3. And it's just asking for the coefficient, so that is good. Okay, next question, we're asked to factorise this completely. Well, the first thing we could do is take out an x. So we can write x 9 minus x squared. And then we can recognise that this bracket here is the difference of two squares. And when we have x squared minus b squared, it's the same as a minus b times a plus b. So here we will have x, open brackets, 3 minus x multiplied by 3 plus x. And that is our final answer there. And now it's asking us to sketch this, showing the coordinates of the points at which it cuts the x-axis. Right, well, to draw a sketch, just set my axis up like this. I have x, I have y. And we need to find where it cuts the x-axis, so that's when this purple square here, when does that equal 0? Well, when x is 0, that will be 0, so therefore the whole thing will be 0. So it definitely goes through 0, 0. Also, when x is 3, 3 minus 3 gives you 0 there. So 3 is also a root. And here, minus 3. When I sub minus 3 into that bracket, we will get 0. So those are the places where it crosses the x-axis. Now, because it's a minus cubic, it means we start at the top, up here, and then we come through downwards like that, and then upwards, then we carry on going all the way down towards the end. Excuse me. And there we go, that is sketched. And then we have a line, y is equal to k, where k is a constant, so y equals lines are horizontal ones. And it says that given that the curve and the line intersect at 3 distinct points, find the range of values for k. Right, so if I draw a straight line across right here, you'll notice that it only cuts twice. And if I draw a straight line across here, again, it only cuts twice. But everything in between those two green lines, any line that I would draw in between them, they would definitely cut 3 times. So we need to investigate when the green lines occur, and where they cut the purple line are at the turning points. So we've got to take our y function, which was equal to 9x minus x cubed, and we've got to differentiate it. So dy by dx is equal to, drop the power down by 1, so 9, and here drop the power down to the front, so 3, and then drop the power down by 1 to a 2. And turning points happen when that equals 0. So that will mean 9 will equal 3x squared. So 3 will equal x squared. So square rooting, x will equal plus or minus root 3. Okay, but it's not, the x coordinate is useful, but actually what we really want is the corresponding y coordinate. So we need to sub one of these x coordinates into the original equation. So the original equation here is y is equal to 9 times x, so we'll do 9 times root 9 times root 3 minus root 3 cubed. So we can do that in our calculator. That would be 9 times by root 3 and then minus root 3 cubed, and we should get 6 root 3. Okay, great. Okay, and that will be this line here, that'll be the y coordinate, so it'll be this line, y is equal to 6 root 3. And by symmetry, this one will be y is equal to minus 6 root 3 because it's a perfectly symmetrical cubic. But you could sub in x equals minus 3 and that would give you 6 root 3. Minus 6 root 3, sorry. So the two lines, or sorry, the k value is all of the lines which are in between all of these lines here. So the k value is in between those two values. So we'd write minus 6 root 3 is less than k is less than 6 root 3. We have to write it in set notation. So we have to start by saying k is a real number dot dot and put this in brackets like this. And that tells me that k is a real number and it's in between these two, but not equal to, because if it was equal to, then it would only cut twice. Question 8. The air pressure P inside a car tyre t minutes after the instant when the tyre developed a puncture is given by this. K is a constant, given the initial air pressure, so that's when t is equal to 0. We have 2.2. We just sub it into this equation and we can find k. So part A, we say that 2.2 is equal to k plus 1.4, and that is e to minus 0.5 times 0. So this is 2.2 is equal to k plus, and e to the 0 is just 1. So 1 times 1.4 is just 1.4. So therefore it follows that k is equal to 0.8. Okay, great. And then it says from the instant when the tyre developed a puncture, find the time taken for the air pressure to fall to 1. So part B, we want the air pressure to be 1. We know k is 0.8, and that's plus 1.4 e to the minus 0.5 t. We can subtract the 0.8 from both sides. So this gives me 0.2 is equal to 1.4 e to the minus 0.5 t. We can then divide by 1.4. So 0.2 divided by 1.4 gives us 0.142. Make sure I keep that in my calculator, and that's e to the minus 0.5 t. And then we can take ln of both sides, and that will cancel out the e. So it'll be ln of 0.142 is equal to minus 0.5 t. And then finally, we just divide through by minus 0.5, and that will give me t. And on our calculator, we will do ln of that previous answer equals, and then we will divide that by minus 0.5. And that gives me 3.89. And it's asked to one decimal place, so that is just 3.9. And that is in minutes, because it says here that t is in minutes. Okay, and now it says a real key word here, rate. So rate means change, which means that you have to differentiate. And it's that which the air pressure of the tyre is decreasing exactly 2 minutes from the instant the tyre developed the puncture. So let's take the that formula for P and let's differentiate it with respect to T. So dP by dt is equal to, well, K was a constant, so that will differentiate to 0. When I differentiate an E function, I take the derivative of the input and I multiply that by the coefficient. So that means I need to times 1.4 by minus 0.5. So 1.4 times minus 0.5 gives me minus 0.7, and then E, and then the input stays the same, because when it didn't differentiate an E function, it stays the same. And we wanted to know what that is when t is equal to 2. So let's just substitute that in. And we get minus 0.7 multiplied by e to the minus 0.5 times by 2. And great. This gives me a value of minus 0.258. That is a negative, and it does say it says the rate at which the tire is decreasing. So I think technically the correct answer is actually 0.258 because that's the rate at which it's decreasing. But this is still acceptable in the mark scheme. Question 9. Given that p is equal to log base 3 of x, find in its simplest form log base 3 x over 9. Well, this is a division, and using log rules we can split it up using subtraction. So we get log base 3 of x minus log base 3 of 9. And log base 3 of 9, we're asking the question, in base 3, what power gives you 9? Well, 3 to the 2 gives you 9, so that is equal to 2. And the next part of the question, we have got log of the square root of x, which we can write as log x to the half, because when you square root it's the same as the power of the half. And then we can write that as a half log x, because using log rules the power can come down to the coefficient. And of course this is base 3. So that's just a half of p. Okay, great. Part B, it says hence whatever I solve this. Well, I'm going to definitely use the hence part and use the information from last part of the question. So this is 2 lots of, and that we worked out was p minus 2. And then this is 3 lots of, what we worked out was a half p, and that's equal to minus 11. Okay, so multiplying out the brackets, I'm going to get 2p, and I'm also going to get 1.5p. So in total, that's going to give me 3.5p. And I'm going to get a minus 4 here, and minus 11. So I'm going to get 3.5p. When I add the 4, it's going to equal, oh my god, add 4 gives me minus 7, and then dividing through by 3.5 gives me p is equal to minus 2. Let's remind ourselves what p actually is. It's log base 3x. So log base 3x is equal to minus 2. So in order to get rid of a log, we need to raise both sides to the power of the base. So I'd write x is equal to, and then base is 3, so to the power of minus 2. And that's equal to 1 over 9. And that is our solution. Let's move on. Okay, we have question 10, and we have a curve and we have a tangent, and we're given the curve and we are told that this tangent is at the point x equals 4, and it says show that L is equal to that equation. So I will need to differentiate the curve to get the gradient function, and we will take the power 2, multiply it by the coefficient to get 2/3, and that's x, drop the power down. This is actually minus 2x to the half, so the power times by the coefficient gives you minus 1, and then we're dropping the power down to minus a half, and then the constant term 3 differentiates to 0. Okay, so I'll then need to sub in the point at which we're inspecting, which the x-coordinate was 4. So this gives me that dy by dx at that point is 2/3 times by 4 minus 4 to the power of minus a half. So just go to my calculator to do that. I'll write 2/3 multiplied by 4 minus 4 to the power of minus a half, and that gives me 13/6. Keep it as a fraction. And then what we'll need to do is we need a y coordinate. So what we'll need to do is sub x into the curve to get the corresponding y coordinate. So sub in, so again at x equals 4, y this time is equal to 1/3 4 squared minus 2 lots of 4 to the half plus 3. And again, let's put that into our calculator. So 1/3 times 4 squared is 16, minus 2 times by 4 to the power of half is the square root of 4, which is just 2, and then plus 3, just to speed things up. So that's 13/3. Okay, so we've got everything we need now. We've got a gradient, we've got an x-coordinate, and we've got a corresponding y-coordinate. So we can use the formula y minus y1 equals mx minus x1. And we can say that y minus the y-coordinate, which is 13/3, is equal to the gradient, which is 13/6, open brackets, x minus the x-coordinate. Okay, whenever I've got a fraction as a gradient, what I can do is I can multiply both sides by the denominator. So timesing both sides by 6 will give me 6y. Timesing 13/3 by 6 will give me 26, so minus 26. And timesing through by 6 will cancel that, which will leave me with just 13x, and 13 times minus 4 is minus 52. Let's bring it all over to one side. Let's have a look how they want it. They want the 13x to be positive, so I'll bring it all over to the right side to get 13x minus 6y, and minus 52 plus 26 is minus 26. Perfect. And that is, yeah, that's good. That was 5 marks. Lovely. Now it says find the shaded region. Okay, the shaded region, right. So when we integrate between 0 and 4, we are going to get all of the purple region. And that's not exactly what we want. So what we will need is to get rid of this region here, this green region. So we need to integrate between 0 and 4 and then subtract that triangle there. Okay, let's first work out the integral. So for part B, I will need to integrate between 4 and 0. And the function was a third x squared, and it was minus 2x to the half plus 3 dx. Right, so when we integrate, we up the power and then we divide by the new power. So upping the power to 3, then dividing by 3 is going to give me 1/9. Upping the power to 3/2 and then dividing by 3/2 is going to give me minus 4/3. Yeah, that's right. And then up the power here is just going to give me 3x. And that's between 4 and 0. Okay, and I can then sub in 4. So I will get 1/9 4 to the power 3 minus 4/3 4 to the power of 3/2, and then plus 4 times 3 is 12. Great, so I get 76/9, and then take away 0. Well, when I sub 0 in, they've all got x's there, so that's just going to be 0. Okay, great. So that means the purple region is 76/9. Let's go back to our diagram. So the purple region was all of this, but then we need to subtract this green region from it. So what I'm going to need to know is this x-coordinate here, where that line meets the x-axis. Okay, so my equation here was the equation of the straight line L. So I can set y equal to 0, because that's where it hits the x-axis. And that will give me 0 is equal to 13x minus 26. So 26 is equal to 13x, so x is equal to 2. Okay, great. So that means x there is 2, which means this gap from there to there, or the base of this triangle, is 2. The height of the triangle, we already worked out what the y-coordinate was. It was 13/3. So the triangle is 2 times 13/3 halved. And if I'm timesing by 2, and then I'm halving, it's just going to be timesing by 1, so it's just 13/3. So we can say that the triangle is equal to 1/2 times 13/3 times 2, which is equal to 13/3. So the total region R is the purple part under the curve minus the triangle, and this will give me, subtract 13/3, which will give us 37/9. Perfect. Okay, tricky question alert. Let's look at this diagram. We've got a circle, we've got a straight line. We're told the circle, we're told the straight line, so it seems innocent enough. And then it says work out the coordinates of the centre and the radius. Okay, well, we need to complete the square. These are the most important numbers here, which minus 10 and minus 8. So to complete the square, I look at the x's and I write x minus 5, because that is half of minus 10, squared, and then I take that number away, squared. And then I do the same for the y's, so I write y minus 4 squared, and then I take that number minus 4 away, squared. And I've still got a plus 32, and that equals 0. Great, so I write x minus 5 squared plus y minus 4 squared. This gives me minus 25, this gives me minus 16, plus 32 equals 0. Minus 25 minus 25 minus 16 plus 32 is equal to minus 9. So I get x minus 5 squared plus y minus 4 squared. Minus 9 equals 0. Add the 9 to the other side, equals 9. And then I can say that the centre is the x-coordinate, which solves that bracket, which is positive 5, and the y-coordinate, which solves that one, which is positive 4, and the radius is the square root of this constant here, 9. So it's the square root of 9, which is equal to 3. Okay. Find the shortest distance between C and L. Okay, we're going to let you into a little secret here, which I don't tell everyone. But to find the shortest distance from a line to a point, it's always going to be a perpendicular. So the shortest distance will be a perpendicular, like that. And it's also going to go through the centre as well. If I were to draw this line like this, it's definitely going to go through the centre of the circle. And if I was to draw it flat like that, it might be a little bit more obvious. So the shortest distance from that circle to that line, maybe it's clearer to see now, is straight up there. And that will go through the centre like that. So essentially what I'm looking for is I'm looking for this straight line, this straight blue line here, that goes through the centre and is perpendicular to the line. So let's find that. First off, let's take this line, let's find the gradient, and then let's take the negative reciprocal. So that line there is, I'm just going to clear this working to get a bit more space. That line there we could write as 2y is equal to minus x minus 6. And then I could write that as y is equal to minus 1/2 x minus 3. So the gradient of this line is equal to minus 1/2. So the perpendicular gradient, let's call it m2, is always equal to minus 1 over m1. So it's minus 1 over minus 1/2, which is equal to 2. Okay, great. So this line here has a gradient of 2. And we also know it goes through the centre point, which we worked out earlier, and that was 5, 4. So let's find the equation of this line. So we'll have y minus y1 is equal to mx minus x1. So this gives me y, we're going to get 2x minus 10. So we're going to get y is equal to 2x minus 6. Okay, so that is the equation of the blue line. And we have the equation already of this purple line. So we can work out where those two meet by solving these two simultaneously. And the purple equation was the same as this one. So let's write that next to it. Y is equal to minus 1/2 x minus 3. So solving these two equations together is going to give me that 2x minus 6 is equal to minus 1/2 x minus 3, which is going to give me 2.5x, and then add the 6 to that side is plus 3. So x is equal to 3 divided by 2.5, which is 1.2. And the y value I can sub back into either of those two. Let's sub it back into the top one. So 1.2 doubled. And then minus 6. And that gives me minus 3.6. Okay, so what do we know? We know that this coordinate here is this point right here. And we also know this coordinate here. So, and we also know that the distance from here to here is 3. So what we can do is we can work out the distance between the green point and the orange point, and then subtract 3, and that should give me this blue distance here, which is what we're looking for. Okay, so let's do that then. Let's find the distance between the centre and the intersection point. And how do we find distance? Well, we do the square root of the difference in the x's, so 1.2 minus 5, all squared, plus the difference in the y's, which is minus 3.6 minus 4, all squared. And then after that, we need to subtract that 3 radius. And that's going to give me that overall distance. Okay, so let's just pop that into our calculator. 1.2 minus 5 all squared plus minus 3.6 minus 4 all squared, and we get 19 root 5 over 5 and then minus 3, and that is our final answer. Okay, question 12, and we have a company makes drinks containers out of metal, and the containers are cylinders, and they have a capacity of 355, and the circular base and the curved side cost this amount, and the top is more expensive, it costs 0.09, and it says find or show the total cost. Okay, so we know that a cylinder's volume is equal to pi r squared, which is the base area, multiplied by the height. And we're told that these cylinders contain this amount of volume. So therefore we could get an expression for the height of the cylinder by dividing through by pi r squared. And that's useful because our overall formula is not going to involve height, so we want to sort of eliminate that. Okay, now what we could do is we can try and find our expression for the cost. So we know that the circular top, we'll start there, will be a pi r squared, because it's a circle, and that will be multiplied by 0.09, because that is how much it costs per centimetre squared. And then we will have a base area, which will also be a circle, but that will be used from the cheaper metal, so that will be multiplied by 0.04. And then we'll have the curved part of the cylinder. So a cylinder looks like this, and the curved surface area that goes around the middle essentially is a rectangle which has a height which is the same height as the cylinder, and then the width or the length along here is the distance around the circumference, so that's 2 pi r. So the curved surface area will be 2 pi r times by h, and that is made from the cheaper material, so that's times by 0.04. Okay, great. Now what we can do is we can collect these two up. The first two terms have a factor of pi r squared. So it's pi r squared multiplied by 0.9 plus 0.09 and 0.04. And then this one over here, we can replace that h with our 355 over pi r squared, and that still needs to be multiplied by this. Okay, these two added together gives me 0.13 pi r squared. Over here we can cancel out a pi, because there's one on top, one on bottom. We can also cancel out r, and that will get rid of the r squared on the bottom. And then I just need to multiply those numbers together. So that is 2 times 355 times 0.04, and that is 28.4. So that is plus 28.4, and then we've still got this one r on the bottom. So we get this, and I believe that is what they've asked for. Yes, it is. Perfect. Okay, now we need to use calculus. So part B, and to find the value of r for which c is a minimum, giving your answer to 3 significant figures. Okay, so we could rewrite this, because when I'm using calculus I want to write my variables as powers. So 28.4, and that is r to the minus 1, because we are dividing by r, so it's a negative power. Now what we can do is we can differentiate this function with respect to r. There's an r squared here, so we times by 2, and then we drop the power down, so that just becomes r to the 1. And here the power is minus 1, so we times by minus 1, and then we drop the power down, become minus 2. And we want that to, it says use calculus to find the value of r for which c is a minimum, giving your answer to 3 significant. So we want that equal to 0, because minimums occur when the gradient is equal to 0 or the derivative is equal to 0. Okay, and when we've got a situation like this where we've got r's here and we've got r to the minus 2, what we're going to want to do is multiply through by r to the positive 2. So that will give me 0.26 pi r to the 3, because r to the 1 times r to the 2 is r to the 3, and that will be minus 28.4, and r to the minus 2 times r to the 2 will cancel, gives you r to the 0, which is just 1. So I can now solve for r cubed by adding the 28.4 over and then dividing by 0.26 pi. So r is equal to the cube root of that. So on my calculator I will go with the cube root of 28.4 over 0.26 pi. And we get 3.26. Okay, great. Part C says using the second derivative prove that the cost is minimized for the value of r found in part B. Okay, so we're going to need to differentiate again. So part C, I'm going to take the derivative of the first derivative, and that will give me the second derivative is equal to, well, that's r to the 1, so times 1 by 0.26 pi, and then drop the power down, gives you r to the 0, which is just 1. And here we're going to do minus 2 times by, we're going to do minus 2 times by minus 28.4 is going to give me positive 56.8, and that is r to the minus 3. Okay, and then I'm going to do sub in the r value which we found into the second derivative, and when I do that I will get a positive number, and we'll just write down exactly what that number is so the examiner knows that we know what we're doing. And we get 2.45, which is greater than 0, thus a minimum. Because when the second derivative is greater than 0, it's a minimum. When it's less than 0, it's a maximum. Great. And then part D, it says hence find the minimum value of the cost. So what we're going to need to do here is sub the r value which we found back into the cost formula right here. So the r value which we found was well, let's just sub it in. The R value was 3.26, and then we are squaring that, and then we're adding that to 28.4 times by 3.26, and we're doing that to the power of minus 1. Great, we get 13. It says to the nearest integer, I believe, so 13. Okay, great. That's that question done. Okay, question 13 is a tricky trig question. What I will always do is I'll write left-hand side here and I'll write right-hand side here. I'll write out the left-hand side like this, and I'll also write out the right-hand side like this. And the first thing I'll notice is that tan can be written as sine over cos. So I'm going to do my substitution there. I can swap out tan for sine over cos. And then these have the same denominator, so I can bring these together to get 1 plus sine over cos. And from here, I'm going to swap over to this side, and I am going to, almost like when we rationalise denominators, when we have surds, I'm going to multiply it by 1 plus sine theta over 1 plus sine theta. Now the reason why I'm doing that, and it's just experience, and I know that 1 minus sine theta multiplied by 1 plus sine theta is actually extremely handy, because when we multiply out this bracket here, we get 1, we get plus sine theta, we get minus sine theta, and we get minus sine squared theta, which simplifies down to 1 minus sine squared theta. And as we know from our trig identities, that this is equal to cos squared theta, because cos squared plus sine squared is equal to 1. So what does this give us in terms of our identity? Well, the top set of denominators when multiplied together will give me this, and then when dividing I'm timesing these two denominators together, and like I've just shown, that gives me cos squared, which is really handy. And now I can divide through by cos, and that gives me just 1 plus sine on the top, and that's all over cos on the bottom, and that's exactly the same as the left hand side. And once we have that the left hand side is equal to the right hand side, we are done. We have proved that those two things must be equivalent. Okay, the next part we have, first off, these two things look very similar. In fact, the only difference here is that theta has been replaced with 2x. So if the blue box is equal to this, then it means it must also be equal to this. So these two green boxes must be equal as long as I do the theta is equal to 2x substitution. So with that being said, we can write that I need to solve the equation cos 2x over 1 minus sine 2x is the same as 3 cos 2x. So that is the equation I'm going to solve, and I'm going to grab some more space and solve it. So that was 3 cos 2x is equal to cos 2x 1 minus sine 2x. And I can multiply that denominator to the other side, and that will give me 3 lots of cos 2x 1 minus sine 2x is equal to cos 2x, I can then expand these brackets like so. I can then subtract a cos 2x from both sides, which will give me just 2 cos 2x now. And then I can factorize, and I notice that they both have a cos 2x in them. So I can take out a cos 2x, and that leaves me with 2, and then minus 3 sine 2x is equal to 0. Okay, so there's two ways that we can make 0 here. We could either have that cos 2x equals 0, or we can have that 2 minus 3 sine 2x equals 0. And in this case here, this would tell me that sine 2x would equal 2 over 3. Okay, we're going to go to our calculator and we're going to do cos to the minus 1 first of 0. And we're going to get 90. So that tells me here that 2x is equal to 90. Just going to quickly check our range. Forgot to check that. And it's between 0 and 90. Okay. Hold on a minute. It says that cos 2x doesn't equal 0. Okay. Right. Well, this solution is then rejected because it tells us already that cos 2x doesn't equal 0. Okay, and the range is between x and 90, so we can double that to get the 2x range. So let's look at this other solution here. So sine to the minus 1 of 2/3 gives us 40.8. So we get 2x equals 41.8. And then to find the second solution for sine, we do 180 minus the first. So I'll have to do 180 minus the first answer. And that one is also in the range for 2x, which is good. So then to find x, we just divide these by 2. So I'll start by dividing this one by 2, which gives me 69.1. And then I'll divide the other one by 2, which will give me 20.9, I believe. Okay, final question says x squared is greater than 9, then x must be greater than 3. This is false, as if x equals minus 4, then x squared equals 16, which is greater than 9. But minus 4 is less than 3. So that's not what the statement says. It says prove that for all positive integers this is divisible by 6. Classic question, this one. Really easy if you know how, really tricky if you don't. So first off, factorising is always your friend. So let's take out an n. Like this. This is a quadratic which can also be factorised to get n plus 1 and n plus 2. And then you'll need to write that this is a product of 3 consecutive numbers. And that's because we've got n, and then the next one is n plus 1, and then got n plus 2. And then we can say, therefore, 1 of n, or n plus 1 or n plus 2 must be a multiple of 3 and at least one must be even, and therefore the n cubed plus 3n squared plus 2n is divisible by 6. And essentially what that means is, because we have a multiple of 3 and we've also got a multiple of 2, when I multiply a multiple of 3 by a multiple of 2, it will give me a multiple of 6. So therefore it will be divisible by 6. And that's proved. And we're done. Hope you found that useful. If you did, please do like the video, please do subscribe to the channel, please do share with your friends, and stick around. If you're in year 12, then I've got lots of A2 content this year and also next year, so stick around, and bye for now.